Hello everyone, today we'll talk about the solution to the problem max chunks to make sorted. This is quite a nice problem with a short intuitive statement, and here we'll be making observations step by step that will simplify the solution more and more. Well, the first simple observation is that it's always possible to sort the array by sorting chunks, because we can simply take a single chunk, which is the whole array, sort it, and we get the sorted array. And of course, if there is some solution, we want to have as many chunks as possible, we can get a worse solution by merging any two adjacent chunks. This is maybe not so clear to see, but it's still pretty easy to see and pretty obvious. So we can merge two adjacent chunks because we have the fact that by sorting the first one and the second one and sorting all the rest, we get the sorted array. So if instead we just merge them together and sort them as a single chunk, the array will still be sorted. It will still be sorted because the elements that we have there are the same. And in particular, that means that at every position, whether or not we can split the array at that position, depends only on what values are to the left of that position and to the right of that position. Specifically, the first k smallest values should be in the prefix of length k for us to be able to split the array after the first k elements. And that is something that's completely independent. All those splits are independent, and we can make them, we can imagine making them in any order. Just, it's possible to split at a given position if the prefix is a permutation of the first k numbers. And since we have a permutation of the integers from 0 to n-1, it's very easy to check if the prefix has all of those numbers exactly once. Because if we have a prefix of length k, it has to have numbers 0, 1, and so on up to k minus 1. So if we remember the biggest value on that prefix, then if that biggest value is greater than k minus 1, then for sure there is a number there that shouldn't be there. We cannot make a split. It cannot be smaller than k minus 1, because we have k minus 1 different elements, and we know that this is a permutation, so it's impossible. And the final version is that it is equal to k minus 1, and that means that we have k elements, and the biggest of them is equal to k minus 1. So this is exactly the numbers from 0 to k minus 1, and we can make a split there. So we'll be remembering the biggest value on the prefix, and of course our result, the number of chunks, and for every position we take the maximum value to be the maximum of the previous maximum value and the value of that position. And now, if after seeing those I elements, of course start numbering from 0, but the values are also numbered from 0, so there is a match here. So after seeing those first I elements, the biggest element is equal to I, then that means that we can split a chunk here. So we increase res by 1. And at the end, of course, we just return res. So this central observation is that it's completely independent of everything else, whether or not we can split an array at a given position. And of course, after we split an array at a given position, let's say that is the position of the first split, then we can essentially forget everything that happened to the left of it. It doesn't matter. So this is a simple greedy solution. The solution is very short. If the task didn't specify that this is a permutation of those integers, we could probably just sort the array and then try to solve this problem, though in that case we probably wouldn't have such an easy condition as this max value condition, but we'll still just have to match that the first k elements, so we have a prefix of length k, then those k elements have to be exactly the first k elements of the sorted array, which we can just use a dictionary to make sure that this happens.